Hello there, you beautiful people, and welcome to this section on numbers. Now, this is a really important section of the course because in here we're going to learn the inner workings of so many things in computing. Things like computer vision, web pages, and even Google Maps all use numbers to get stuff done. Now, this lecture is just an overview of the coming section, and it should serve as a briefing for what is about to come. But by the end of the lecture, you should know what we're doing next and be super excited to jump right in and start using numbers in Python. We're going to start off, as always, with the basics. The first lecture will cover how to do basic arithmetic in Python. That is addition, subtraction, multiplication, and division. And once you've learned all these, it's quite possible that you'll never need to do maths in your head ever again. And once we've got the basic arithmetic down, we're going to start doing more complicated processes and learn about how we can control the way that the computer will work the answer out. This is very useful and is going to give us a lot of confidence when doing rather complicated things later on. After that, I'm going to introduce you to a new data type called the float. And yes, floats are as cool as they sound. Then we're going to jump in and create our first project. We're going to tie together what we've learned about variables in the last section, along with what we're going to learn about numbers in this section, in order to make a health potion for a video game character. Our project will be able to deal with different game difficulty levels and will really give you a good demonstration of how numbers are used to make things work in computer programs. This project will also introduce us to the Python random module, which we will use to make a random number generator. By doing this, we will learn how to use Python libraries, and this means we can leverage work done by other people to make our code even more awesome. After that, for those of you who are interested, we're going to cover other mathematical topics such as rounding, powers, square roots, some basic trigonometry, and go into more advanced topics using the Python math module. This will be particularly interesting to those of you who have come from scientific or mathematical backgrounds and want to see what Python truly has to offer. Finally, we'll have a section review, and then there's going to be plenty of coding challenges for you to have a go at to check that you fully understand the concepts covered in this section. So hopefully you have a good idea of where we're going to be going in this section, and if you're anything like me, I bet you can't wait to get started. Let's get right into using numbers in Python. Hello there, you beautiful people, and welcome to the first lecture in the numbers section of the Python Bible. Now, of course, no numbers section worth anything would be complete if it didn't tell you how to add, subtract, multiply, and divide, now would it? In this lecture, we're going to do a quick run-through of all the basic mathematical operations, and also a very useful one called the modulo function, which might be new to some of you. We're also going to introduce you to another variable type called the float, and go over a special difference between doing maths in Python 2 and doing maths in Python 3, which can trip a few people up. So by the end of this lecture, you will be able to add, subtract, multiply, divide, and use the modulo function on numbers in Python, and that's going to serve as an excellent and strong foundation moving forward. You'll also have a deeper understanding of what operators are, and you'll also be familiar with a new variable type, which is pretty cool, right? So we have a lot to do, so let's boot up idle and get started. Alright then, so how does arithmetic work in Python? Well, all mathematical operations, like adding, subtracting, etc., all need a mathematical operator. A mathematical operator is just a fancy word for a symbol that lets us do a certain mathematical task, like adding or subtracting or dividing or whatever. So let me show you what I mean. Let's say we wanted to add together 2 and 3. Well, we would type 2, just like in here, just type the number 2, then the addition operator. In Python, the addition operator is just a plus symbol, which, makes sense, right? And then the number 3. When we hit enter, Python is going to know, because of the addition operator, to do an addition between 2 and 3. So all we have to do is type 2 plus 3, Python's going to do the rest and give us back 5. The key point that I'm trying to hammer home here, it's the operator that tells Python what it needs to do. So for example, what about subtraction? I bet you can guess what the subtraction operator is, right? That's right, it's just a minus sign. So let's say if we wanted to subtract 20 from 100. The way that we do that is 100, subtraction operator, 20. And when I press enter, Python's going to do 100 minus 20, and it's going to give us 80 back, which is correct. We can also combine together these operations. So for example, if we type 100 plus 20 minus 80, what that's going to do is it's going to give us 40. Okay, so now that we have addition and subtraction down, we come to multiplication, the bad boy. Right, so the multiplication operator is an asterisk or a star. You can find this by pressing Shift and then 8 on your keyboard. It looks basically like this. Okay, so the way that you do this, let's say if we wanted to find what 2 times 2 is. Well, for that we need the multiplication operator. So 2, multiplication operator 2, 2 times 2, Python's going to give us back 4, which is correct. Now, as a matter of style, it's always good to put a space around the operator. So, like, instead of just typing 2 times 2, it's better to do 2 space times space 2. Just like that. And this just makes it look nice, really, and just a bit less cramped. So that's something you might want to bear in mind. Now we come to division. The division operator in Python is the /. Okay, just like when you're going to a website or something. It can be found next to the question mark on your keyboard. But anyway, if we wanted to find what 2 divided by 4 was, we do 2 division operator 4, and it's going to give us 0.5 or 1/2. Another example, we could do 10 divided by 5. It's going to give us 2.0. Interesting, isn't it, the way that we've got this 0.0 instead of just 2. Now, if you're following along on Python 2, or if you've ever used Python 2 before, you'll find this a bit strange. Because one thing that Python 2 used to do was every division would just give back a whole number. Okay, so if I did 1 divided by 2, it wouldn't give me 0.5, it would just give me 0. And that used to make all sorts of problems, okay? Used to mess everything up sometimes if you didn't catch it. But in Python 3, that has been, I guess, fixed. The problem's kind of been removed. So the divisions now always give back a decimal number. But how is it actually giving back a decimal number? Because numbers in Python, and I guess in most programming languages, they're not all created the same. Okay, there's 2 different types of data that represent numbers. The first type we're already familiar with is the integer or int. So let's say let's take the type function of the number 2. It's going to tell us it's an int. If I take the type function of 0.5, we're going to get this other one here called a float, or a floating point number. A floating point number is just a fancy way of saying a decimal number, basically. So we've got this completely different data type called a float that allows us to get extra levels of precision in our numbers, so we can go to decimal places rather than just dealing with whole numbers. This is kind of more or less automatically done, but it's something to bear in mind. Numbers are not all the same. They're basically 2 different data types, one for whole numbers and one for numbers that have a decimal point. The reason there's this difference is because basically, if you want more levels of precision in your numbers, you need to be able to store more information. So floats actually take up a bit more space in your computer program, a bit more memory than integers do. So a float takes up 16 bytes of memory, whereas an integer in Python only takes up 14 bytes, which is actually rather large as far as integers go. I think Java, it's only 4 bytes. So in Python, a float is 14% larger than an integer in Python, but you get all that extra precision. So it's just something to bear in mind. You've got 2 options available to you. Yeah. So with division out of the way, let's move on to the last topic in this lecture with regards to these operations. Quite quick, right? Called the modulo function. Now, the modulo is weird, but it's very useful, and it basically allows us to find the remainder of a division. Okay, so the modulo operator is the percentage symbol. So, and you can find this in case you're looking for it. It's pretty much just you press Shift and then the number 5 on your keyboard. So, for example, if we did this 5 modulo operator 3, we get 2. And why is that? Well, the reason is, it's not because 5 minus 3 is 2. No. The reason is because 3, if you divide 5 by 3, 3 will go into 5 once with remainder 2. So let's try another example. If I did 10 modulo 2, we're going to get 0. Why? Because 2 goes into 10 5 times and there's nothing left over. So the modulo returns 0. Basically, 10 is exactly divisible by 2, so there's no remainder. What if we do 7.5 modulo 5? Well, that's going to give us 2.5. It's going to give us 2.5, and the reason for that is because 5 goes into 7.5 once, and 2.5 is what's left over. So you can see the modulo operation, although it's a bit weird, it gives us the remainder of a division, which is sometimes quite useful. So yeah, I mean, we've really covered quite a lot in this lecture. I mean, as far as content there, we've learned how to add, subtract, multiply, and divide, as well as use the modulo function. And you've also learned about a key difference between numbers in Python. They're not all the same. You've got integers and you've got floats. And you've also learned about a difference between Python 3 and Python 2. Python 2, whenever you used to use division, it always used to make it as integers. There was no concept of floats during division unless you directly express that you wanted floats. But in Python 3, you don't have to worry about this anymore, and it won't cause any problems when you're doing it. So divide away, I suppose. So what have we got next? Well, in the next lecture, we're going to learn about how we can combine all these operations together to make rather advanced operations. And we're also going to learn how to make sure Python works out the answer in the way that we want it to, rather than it calculating something behind the scenes. Now, this is a very useful skill, and it will stop things going wrong and you not being able to notice it. So it's very useful to know whenever you work with numbers in Python. And as usual, I can't wait to show it to you. So I'll see you in the next video. The great thing about computers is that they will do whatever we tell them to do, and they'll do it very, very quickly. But at the end of the day, computers are just machines, and they can't really think for themselves. Just yet, anyway. So sometimes we think that we've told the computer to do one thing, but in fact we may have told them to do something totally different, and one particular time when this can happen is when we're doing calculations. So in light of that, in this lecture, we're going to go over some common mistakes when doing maths in Python and on computers in general, and we're also going to go over how to prevent them from happening. And by the end of this lecture, you'll know how to order your mathematical operations in Python to prevent things from going wrong. So let's boot up idle and get started. Okay, so here we are in idle, and let's say we want Python to work out the answer to 2 times 5 minus 1. Okay, so 5 minus 1 is 4. So 2 times 4 should give us 8, right? So when I press enter, oh, we get 9. But why does that happen? Now, the reason we got that issue in the previous example, where Python gave us an unexpected result, is because mathematical operations don't always follow what makes sense in our head, but they actually follow what's called the BODMAS ordering system. Now, the BODMAS ordering system is just 6 letters that represent different mathematical operations, and whatever is at the top, basically close to the letter B, gets ordered first or gets more priority, and what is towards the bottom, by that I mean close to the letter S, gets lower priority. So what's the letter B? Well, the letter B stands for brackets, or you may have heard of them called as parentheses. So whatever you put inside brackets is going to be executed first, because B is at the start of BODMAS. After that, we have order, which refers to squaring numbers, cubing numbers, or raising any number to the power of something else. Okay, so cube roots, square roots, all that stuff. That goes second. Then we have division, which is, where you divide 2 numbers. Then we have multiplication, where you multiply 2 numbers. And no points for guessing, A stands for addition, and S stands for subtraction. So the main takeaway from this is that brackets can be used to force operations to occur in a specific order. So with that in mind, let's have another look at the example we just did now to see if we can get the answer that we wanted. So here we are back in our shell, and let's have another look at our equation or our calculation to see what might have gone wrong. We wanted this calculation to give us the number 8 because we thought 2 times 5 minus 1 should give us 8, because 5 minus 1 is 4, and 2 times 4 is 8, right? But that didn't happen. It gave us 9, and the reason why is because Python follows the BODMAS system, and in BODMAS, multiplication happens before subtraction. So what actually happened is Python did this multiplication first, it did 2 times 5 and got 10. Then it subtracted 1. 10 minus 1 is 9, which is the answer that we got. So we want to get 8. And the way that to do this, we need to force 5 minus 1 to be calculated first. So to do that, we can do 2 times and open up a bracket and put 5 minus 1 inside the bracket. Okay, so now, because brackets are at the start of BODMAS, 5 minus 1 is going to be forced to be calculated first to get 4. Then 2 times 4 should give us 8. So there we are. We've got the same numbers on the screen, but just by using BODMAS to our advantage, we've actually got a completely different answer. And this is something to bear in mind because, you know, if we'd just gone ahead and wrote this line of code and didn't think about it again, we might think that it's working correctly, but it's actually not. It gave us a different answer to what we wanted. So by using BODMAS and knowing about it, we can actually control the answers that we get and make sure that the maths that we do in our code is free from errors. The concept that mathematical operations have different orders as dictated by the BODMAS system is a really useful thing to keep in mind whenever you work with numbers in computer programming, because it'll stop your code from doing something unexpected and it'll stop really rather hard to spot errors actually cropping up. So when in doubt, use brackets. I mean, they're free after all. In the next lecture, we're going to build our first mini project, and in this project, we're going to imagine a player that has just walked over a special health potion in our game that gives them a random amount of health. We're going to make a random number generator that can be used to randomly generate some health for your player, and then update their health depending on the difficulty system. So it's going to be super awesome, so I'm not going to waste any time here, and I'll see you in the next video. Hello there, you beautiful people, and welcome to our very first project. I hope you're excited. In this project, we're going to be making a health potion for a video game. That's right, we're officially game developers. High five. So the scenario is, we have a character, who I guess kind of looks like this, who has some health. Let's say he has 45 points. We imagine that this character has walked over a health potion, and the health potion magically increases their health by a random amount. I guess in this case, quite a lot. But the game also has 3 difficulty settings: easy, medium, and hard. Now, depending on what difficulty is selected, the amount of health that the person gets from the potion will change, and this will be less on higher difficulties. So in this lecture, we're going to be using variables and numbers to create the functionality required for this health potion to work, and we're also going to use Python's random module to help us build a random number generator. By the end of the lecture, you should have a rock-solid understanding of how numbers are used in computer programs to make things work behind the scenes, and you'll also know how to make a random number generator in Python. This lecture is going to tie together a lot of what we've covered so far, and should be a really valuable learning experience, so I hope you're excited. Oh, and make sure to follow along with me for maximum learning. We have a lot to do, so let's boot up idle and get into it. Alright, so the first thing we're going to need to do is create a new script to hold all our code. So I'm going to go up here to the File tab, press New File, and we're going to see this thing here. I'm going to save it on the desktop in my Python Bible folder, and I'm going to call it health.py. Now make sure you remember the .py file extension when you're following along. So let's maximize this, and we're good to go. Right, now that we've done that, the first thing we're going to want to do is give our character some health. Health is a rather complicated topic conceptually, as I'm sure doctors will tell you, so we need to think of a way that we can represent health in a simple enough way that a computer can understand it. I know, we can use a number. Health is going to be a whole number in this game, so we're going to want to use the integer data type, because that's what we use for whole numbers. We'll obviously want to store the player's health somewhere and refer to it and update it later. So for this, we're going to need to create a variable called health, and we'll need to give it a certain value. Let's say the player's health starts at 50. Here's a micro challenge for you to test what you really learned in the last section. I want you to pause this video and create a variable called health and give it the value of 50. Go ahead and pause this video now, create the variable called health, and then unpause the video to see if we did it the same way. So how'd you get on? Did you manage it? The way that I do it is I type health equals 50. Now if you got the same as me, then congratulations! You're well on your way to understanding variables and numbers in practice, which is brilliant. So now what we've done is, we've managed to create a representation of the player's health using a variable called health. The value that health has starts at 50, but this number is going to change as the player gains health from our potion. Now our potion is going to give the player a random amount of health. The amount of health it's going to give them is going to be a random number between 25 and 50. Now we don't really want to create the code required to generate a random number from scratch, which I understand is quite a complicated task. The good thing is we don't need to. Python has a built-in module that we can use called the random module, which can generate random numbers for us. The way that we use Python libraries is to import them. You usually do all of your imports at the top of Python scripts, so let's go up there and import the random module. Let's move this down. All we've got to do is type import, which you can see goes yellow, and then the name of the module. Seeing as we're importing the random module, we're just going to type import random. And say when I save the file, that's going to allow it when it runs for Python to import that file. So perfect. One thing that you should notice is the way that the import word here went yellow. This is idle's helpful way of showing us that import is an important word in Python, or a keyword, and this colour highlighting can be useful when checking for spelling mistakes. So let's say, for example, I forgot the R, and I put import. You can tell that now that it's gone black, which would let me know that potentially I've made a problem, instead of because I was expecting it to be yellow. So let's have a look at the Python random module, and what it makes available to us. One way to do this is we can open up the Help tab inside of idle, and click on this Python docs link. Or you can press the F1 key on your keyboard for a shortcut. Either way, we're going to see a window that looks something like this pop up, and this contains all the Python documentation. This documentation details all the built-in modules and functions that are available with Python, and other useful pieces of information. So it's a great resource. Now at the top here, as we're looking for a random module, we're going to click Modules. And here's an alphabetical list of all the modules, which is quite convenient for us to browse. Now, as we're looking for the random module, let's click the letter R here and see what comes up. Awesome, the R's not that long, and you can see random is right at the top, so let's click on that. And this has opened up the documentation for the random module. As you can see in here, we have all sorts of useful information, which you can browse through if you wish, but to save some time, I'm just going to show you the randint function. So when I browse to that, here it is. So random.randint. So this function will give you a random integer, okay? And it gives you the information here on how it works. It's going to return a random integer, what they're going to call n, such that n is between a and b, but it can be equal to both of them. So it's probably a bit easier if I show you what this is in practice. Let me just show you how this works. So let's head over to the shell. Where's the shell? Let's type it in here, don't I? Let's open up the shell. This is different to our script, by the way. This is just the raw Python shell. If I type import random, okay, that's worked, that's fine, we haven't got any error. Now I want the randint function. So for that to work, I have to type the module name, then a full stop or a period, and then the function that I want to use. So random dot randint, and let's say I put, I don't know, 10 and 20. Okay, so Python has given me a random number between 10 and 20 that can be equal to both. So if I just run that again, random dot randint, let's say 10 and 100. You see, it's giving me 45. So basically, this is just going to be, and if I type that again, 56, 54. By the way, this is a useful time to mention. On the shell, if you want to just repeat a command, put your cursor here, hit the enter key, and it will copy and paste it to the next line. But as you can see, it's giving us a random number between 10 and 100. So that's quite useful. Now, if you remember, I said that we wanted the health potion to generate a random health value between 25 and 50. And store that in another variable. So here's another micro challenge for you. I want you to create, on another line here, to create a variable called potion health and set that equal to a random number between 25 and 50 using the random module's randint function. So pause this video now and go ahead and try to use the randint function to create a variable called potion health that is between 25 and 50. How'd you get on? Did you manage it? Well, here's how I would do it. I would type on this line, I'd type potion underscore health because, well, first of all, we can't have a space in our variable names. And this is the convention for how you name your stuff, all lowercase with underscores for spaces. And I'd assign that a value, a random value between 25 and 50. So to do that, I need the random.randint function. And to have it between 25 and 50, I give this 25, comma 50. So if you got that, then perfect. But if it was a bit hazy and a bit difficult to understand what happened, just feel free to rewind the last few minutes to make sure that you have a decent understanding of how modules work in Python. Just as a quick overview of how it works, we've imported the random module, and which you can see is the same here. And inside the random module, there are loads of functions, one of which is called randint. So, I mean, we're going to cover functions much later in the course, but I just want you to understand kind of what's going on. So what we're saying is, in the random function, put a period, this function name, randint, which we're going to give 25 and 50, Python's going to get a random number from this, isn't it? It's going to get, I don't know, say 35. Once it's got 35, it's going to stick that value in the box that we've called potion health. So if you understand more or less what I'm talking about, then brilliant. I'm not expecting you to understand the ins and outs of this, but if that kind of makes conceptual sense, then that's brilliant. We've now got a certain amount of health that the potion is going to give our character that we can refer to later on. Phew, I think that's a good time for a break, don't you? So let's have a quick review of what we've done so far in the project. We started this lecture with a brief of this project and what we'll be making. We found out that we're making a health potion that can be used in a game to give a character a random amount of health, depending on the difficulty level. You then went ahead and applied what you've learned about variables and numbers so far to create a variable called health and give the player an initial health value of 50. After that, we decided that we wanted to use a random number generator to help us with making random numbers for our potion to save us coding it all from scratch. So we checked out Python's random module. We had a quick overview of how to look at a module's documentation and also how to import a module into our code using the import keyword. All we had to do was type import and then the module name, which in this case was random. Finally, we used the randint function inside of the random module to generate a random integer between 25 and 50 and stored that value in a variable called potion health. I mean, we covered quite a lot in this lecture, and I'm really proud of how far you've come in such a short space of time. We're really starting to touch on some advanced topics, such as module importing and functions. So if all of this makes sense to you so far, then well done, genius. We aren't there yet, though. There's still some way to go to finish off our health potion project. In the next video, we're going to find a way of adding together our potion health to our player's overall health. And we're also going to find a way to implement a difficulty system so that a player will get less and less health from our potion when playing on harder and harder difficulties. I'm really excited to finish off our project, so I'll see you in the next video. Hello there, you beautiful people, and in this video we're going to finish off the health potion project, which is going to be quite an achievement. So in this lecture, we've got quite a few things to do. First of all, we're going to make it possible to add the potion health to the original health of the user, or the character. Then we're going to make the program print out how much health the character has, so we can see if our code is working or not. After that, we're going to implement a difficulty system so that the potion gives less health on higher difficulties. By the end of this video, you'll have a functioning model for a health potion that you'll be able to show your friends. Pretty cool, right? Now, not only that, but you'll have tied together everything you've learned so far in the course, and you'll hopefully have a rock-solid understanding of variables and numbers. So let's get into it. Alright, so this is where we got to last time, back in our health.py script. Now, the next thing that we need to do is to take this potion health right here, which is a random number between 25 and 50, and add that somehow to the original health that the player had. So, as a micro challenge to you, I want to see whether you can do this, okay? What I want you to do is to store in the box called health the value of what the health is currently, what the health is now, plus the potion health. Okay, so let's see if you can do that. Pause the video and try on this line, so a couple of lines down, just try and store in the health variable whatever the current health is, plus the potion health. And check back here to see how you did. So how'd you get on? Did you manage it? Well, here's how I'd go about it. I'd type health equals health plus, let me shift my mouse, health equals health plus potion health. Okay, so what's going down here? Well, we've got a box that's called health, and we're using the assignment operator to stick a new value in it. So what are we putting in? Well, we're taking whatever the value of health is now. So Python's going to look inside the health variable and see 50. So we've got 50 plus potion health. So let's say potion health was 30, for example. Python is going to evaluate whatever's on the right-hand side of the assignment operator and see 50 plus 30, and it's going to add those together to get 80 and store that back in the health variable. You can kind of overwrite a value using itself, which is pretty cool, right? Alright, so to check that everything is working correctly, we need to now print the new value of health onto the screen. So let's make this another micro challenge. I want you to figure out how to use Python's print function to print the new value of the character's health onto the screen. So go ahead and pause the video now and use the print function to print the health value onto the screen, and come back when you're done to see how you did. So how'd you get on? Hopefully it went well. Here's how I'd have done it. So we want to print the new updated value of health. So simply, I would have just typed print health. Now there's one thing I want you to notice here. Can you see the way that the word print has gone purple? Well, just like import up here went yellow when idle showed us that it had a special meaning, likewise print has also gone purple to show that it's a built-in function. So when you see words go purple, that means they're a built-in Python function or a reserved word. So that's just idle letting us know that we spelt things right, or that we're doing things correctly. Now up here we kind of put the new value of health inside a box called health, didn't we? Now to print that out, we just have to type the variable name. So Python's going to look inside the box called health, get the value, which let's say it's 70 or something, and when we print it, it's going to show up on the screen. So if I save this file by pressing Control and S, alternatively you can go File and Save if you're old school, and then we can click Run, and what we see is 97 pop up on the screen, which is pretty neat. So what happened was, our health started at 50, potion health became a random number between 25 and 50, which in this case I guess was 47, and we added that to the original health, so 50 plus 47 is 97, and we printed 97 to the screen. So that's pretty neat, right? So what have we got next? Right, the last thing we need to do is we need to make some kind of difficulty system. So what we want to happen, let me just close this here. What we want to happen is for the player to get less and less health at higher difficulties. Now the simplest way that I can think of doing this is to create a variable called difficulty and set that equal to a value between 1 and 3. 1's going to represent easy because it's the lowest difficulty, 2 is going to represent medium, and 3 is going to represent hard. Again, the thing that I'm trying to get across is the way that we're using variables to represent concepts in the real world. So you can see how useful numbers are, right? So let's make this step for now. As a micro challenge, at the top here, near where we've defined health, so let's say here, I want you to define a variable called difficulty and set it to easy mode by default. Okay, so just set it to easy mode using the number scheme we mentioned earlier. 1 being easy, 2 being medium, and 3 being hard. So create a variable called difficulty, set it to easy, and then come back to see how you did. So how'd you get on? Well, as we're setting the difficulty to easy mode, I'd do something like this. Difficulty equals 1. Simple as that, right? If you got that, then brilliant. You understood what I was talking about. Now, if they were on medium mode, we'd just say difficulty equals 2, or if they're on hard mode, difficulty equals 3. But for now, we're on easy. So now we need some way to allow this difficulty to affect how much health the potion gives our player, which means we need to modify our potion health variable using this difficulty value. So one way that I can think of doing that is simply to just divide the health that's here by the difficulty. Because what's going to happen is, as the difficulty gets bigger, we're going to be dividing by a bigger number, so the potion health will become smaller and smaller, which means on higher difficulties, the player is going to get less and less health from the potion. Makes sense, right? So if I run this now, well, Python's going to tell me to save it, so I'll save. And we see we get 98.0. So that's pretty good, but now we have this decimal point that's popping up that we didn't have before. Now the reason is, it's because, do you remember a few lectures ago, I said that whenever you divide in Python 3, you get a float. And a float is different to an integer. Floats are decimal points, and integers are whole numbers. And we want this as a whole number, this potion health. What we've got at the minute, we've got a float plus an integer, and that's going to give us a float, because it can't lose the precision. It can't lose the decimal point values, so it needs to just add it. So what we need to do is we need to convert this value, whatever it is, into an integer. And the way we can do that is with something called casting. So casting is where basically you force a certain piece of data to become another type. So we want to force it to become an integer. So what I can do is I can type int, open the brackets, and now you can see actually that it's gone purple, just like print went purple down here, showing that we've got something right. And we're going to put inside the brackets all of this stuff. And what that means is that it's going to calculate potion health, just like before, and convert it into an integer. So now when I run that, you can see now, oh, they got the maximum health. Brilliant. So what that means is we now only get integers out because we got rid of the float in our calculation. You can convert between pretty much all kinds of compatible data types in Python. But for now, this is how you do integers, convert to integers. You can convert to floats as well using the float keyword like that. And what we can see is that as I increase the difficulty, say I give it to 3, and now it's on hard mode, what we're going to see is that on average, I mean, they did quite well there, 61. On average, they're going to get much lower than if I put the difficulty on 1. So now it's much more likely they'll do higher. So you can see they got 80 there, whereas before they only got in the 60 range. Awesome. We now have a fully functioning health potion with a swanky new difficulty system. Why not share the code you've made with your friends and show them how it works? I bet they'll be very impressed. So let's just go over really quickly what we've done in this lecture. We started off by allowing our script to update our player's health with the random health that Python generated. This basically means we've added health to the player. This concept of overriding variables is very useful, and you should make sure you've got it down as it comes up all the time. After that, we moved on to make our script print out to the screen the new health of the character using Python's print function. This was just so we could check that everything was going as expected. After that, we implemented a difficulty system, again by using numbers to represent the different difficulties. Numbers are amazing for representing real-life concepts, and we use them here to represent difficulty. But we found that by doing it in my chosen way, we got a little bit of an issue where we would get health values with decimal numbers. This meant that we were getting float variable types instead of integer variable types, and we only want to work with whole numbers in this project. So to fix this, we used casting. Casting is simply where we convert one data type into another. In this case, we converted a float into an integer by using Python's int function, but you can convert from an integer into a float using Python's float function if you wish. Whew, I mean, that really is quite a lot we covered in this video. So I hope you're really proud of yourself for finishing the project, and I hope it serves as a badge of honor that you fully absorbed the variables section and the numbers section of the Python Bible. Now in the next lecture, we're going to be talking about some extra things that Python can do with numbers, such as trigonometry, rounding numbers, powers, square roots, and other useful things which may be interesting to you by using the math module. However, this lecture is optional, so take it if you feel like it, but if you're not particularly interested, then feel free to skip it and head over to the section review for a quick recap of what we've learnt in this section. Either way, I'll be there, so I'll see you in the next video. Hello there, you beautiful people, and first of all, I commend your dedication for stepping up to take this optional lecture on useful Python maths functions. This kind of dedication to always find out more makes it very clear to me that you're going to do great in this course and in your future work as a Python programmer. Nice one. Now in this lecture, I'm going to share with you some things which you might use quite often if you do rather maths intensive or engineering related work with Python. These include things like rounding numbers, trigonometric functions, exponentials, logs, squaring numbers, cubing numbers, etc. Now for this kind of stuff, you'll need to use Python's math module. Feel free to check out the documentation for Python's math module for yourself in the Python docs like I showed you earlier. But in this lecture, I'm just going to cherry pick a few examples to give you a feel of what's possible. But there are many more things for you to explore and play with to see what you personally might find useful. By the end of this lecture, you'll have more of an idea of what Python has to offer maths-wise, and I'll also point you in the direction of a few more advanced libraries or modules for you to look at. We obviously have a lot to do, so I'm going to be going quite fast to fit it all in. Don't worry if I go too fast, just listen to the bits that are relevant to you and rewind them, otherwise just ignore me. Alright, let's go. So a common thing you might want to do in Python is to round numbers to the nearest integer. Now this is done using Python's built-in round function. So for example, if we have the number 2.1, by typing round 2.1, Python is going to round this number down and give us back the number 2. Just like that. Likewise, if we have the number 1.5, by typing round 1.5, Python is going to round this up to the next whole number, which is also the number 2. Something to notice here is the way that round has gone purple. This shows that it's a Python built-in function. It's just one of the basic standard functions that Python already comes with. But Python's basic math support is not all that powerful. So to use some more powerful abilities, we can import Python's math module, which is full of all sorts of functions and stuff in there. So here's a micro challenge for you. Using what we covered in the last few lectures, try to import the Python math module. So go ahead and pause the video now, head over to your shell and import Python's math module in the same way that we imported the random module, and come back here to see how you did. So how'd you get on? Did you manage it? Well, if you did something like this, you open up your shell and you typed import math, and you pressed enter and got no errors, then fantastic, that was exactly it. Because we know the module is called math, all we had to do was type import and then math, okay? Because whatever the module name is, you put here. So brilliant. Now sometimes you only want Python to round up or round down to the nearest integer, regardless of the value you're rounding. So for example, if I just do the regular round of 1.5, because it ends in 0.5, it's going to round up, isn't it? But what if we wanted to force it down to 1? Well, for that, we could use some of the built-in, well, not built-in, but use some of the math module functions. So for example, if I just do round of 1.5, we're going to get 2. But if I do math.floor of 1.5, you can see it rounds it down to 1, because that's using the floor function inside the math module, and that will give us 1. Likewise, if I do, I don't know, math.ceil of 2.1, that's going to round up to 3. Ceil is short for ceiling, like the ceiling in a room. So instead of rounding down to 2, which it would normally do, like up here, it's rounded up to the next integer, which was 3. Along with having functions inside of it, Python's math module also has a few useful values already built in, such as pi and e, the exponential. So for example, if we type math.pi and press enter, we see that we get pi to quite a few decimal places. And likewise, if we do math.e, we're going to get the exponential to quite a few decimal places, which is useful because you don't have to type these up and, it saves you just a bit of work. Now, Python's math module also has standard trigonometric functions such as sine, cos, and tan, as well as inverse trigonometric functions such as arcsine, arccos, and arctan already built in and ready to go. But do bear in mind that these functions take numbers in radians and not degrees by default. So for example, we know that the sine of pi by 2 is 1, right? So if we type math.sine of math.pi divided by 2, we get 1, as expected, but notice the answer that comes out is a float. Likewise, if we type math.sine of pi, which is just math.pi, then we're going to get 0, or almost 0. As you can see, we get 1 times 10 to the minus 16, which is a very, very small number, but it isn't exactly 0. The reason it's not exactly 0 is because when we entered math.pi up here, that is only an approximation to pi. So to get this to be actually exactly 0, what we might want to do is do math.floor of math.sine of math.pi. So basically we take that number and put it in there, and that's going to round it down to 0, as expected. So likewise, we can use cosine, for example. We know that cosine of 0 is 1. So if we do math.cos of 0, we're going to get 1. And to show an example of taking the inverse of the sine function, we can do math.asine of 0, and we can see that we get 0 back. Likewise, if we do math.acos of 0, we get 1.5707, which is pi by 2, as expected. If you check on the cosine graph, that's what you need. We can also use the math library to find the hypotenuse of a right-angled triangle using the Pythagorean theorem. Now, as we know, the hypotenuse of a right-angled triangle, where A and B are the small sides, and then C is the hypotenuse, the long side, you can use the square root of A squared plus B squared. But for a right-angled triangle with short sides of lengths 3 and 4, the hypotenuse is 5. So we can check this by doing math.hypot 3 and 4, and we're going to get back 5, because 3 squared is 9, 4 squared is 16, add those together you get 25, square root of 25 is 5. This function is also useful for finding resultant vectors in vector algebra as well. We can also square numbers and cube numbers in Python very easily using the math.pow function. So for example, if we want to get 2 to the power of 3, or 2 cubed, we can type math.pow of 2 to the power of 3, and that's going to give us back 8. We could alternatively, as a shortcut, we could do 2 times 3, and that's also going to give us 8, but as an integer instead of a float. So this is available without using or without importing the math module, and is a shortcut that's just generally built into Python. But you can see there's a difference in the variable type that comes out. So let's take another example. Let's say we wanted to find 9 squared. We could do math.pow of 9 to the power of 2. We're going to get 81.0, or we could do 9 star 2. We get 81 as an integer. You can also find the exponential of a number using the math.exp function. So for example, if we wanted e to the power of 2, we could just type math.exp 2, and that's going to give us 7.39. Which if you type it in the calculator, you get the same thing. The same goes for natural logs. As we know, the natural log of an exponential always equal 1. So we can see this result when we type math.log of math.e as a constant. We're going to see 1 come out. So that works fine. But if you want the base 10 log or base 2 versions of log, you can use the log10 function, or sorry, the math.log10 function, or the math.log2 function, respectively. For example, if we do math.log10 of 1,000, what we're going to see is 3, because 10 to the power of 3 is 1,000. Likewise, if we do math.log2 of 8, we're going to get 3, because 2 to the power of 3 is 8. So there we have it. That was a really quick run through of some of the things that are available in the Python math library. Of course, you aren't expected to memorize any of this, and I'm not even expecting you to need to use most of it. Just use this lecture as a starting reference in the future if you ever need to do more mathematical things in Python. You've got it there for life. So one thing you should be able to take away from this lecture, however, is that Python is very capable of doing mathematical processes, and there is plenty of functions available for that kind of thing. If you want more in-depth stuff, you might want to check out the NumPy and SciPy libraries for more advanced functionality that is best suited for data analysis. But well done, you've survived the gauntlet and made it to the end of the numbers section of the course. In the next video, we're going to have a quick review of this section to make sure you've got all the concepts down, and then we'll move on to a quiz and coding challenge and stuff like that. So without further ado, I'll see you in the next video. Hello there, you beautiful people, and congratulations! You made it to the end of the numbers section of the Python Bible. We've covered so much in this section, so let's just take a step back to see just how far we've come. By the end of this lecture, you'll be feeling pretty fantastic about yourself for all the stuff you've covered, and you'll be pretty confident that you've fully digested all the information. And if not, you'll know what parts of this section you might need to brush up on. So let's get into it. We started by having a look at how to do basic algebra in Python. In that lecture, we introduced the concept of mathematical operators, which we said were just special symbols that let Python know which mathematical operation to do. We learned how to add, subtract, multiply and divide numbers, as well as learning about the modulo function, which just finds the remainder of a division. You also learnt about a key difference with division between Python 2 and Python 3. In Python 2, division always used to give you back an integer or a whole number, which used to cause all kinds of problems. But now in Python 3, that's been fixed, and divisions always give back floats. We then introduced what a float actually was, and we learned that floats are just a data type for storing decimal numbers, which are very useful and they come up all the time. You also learned how to control the order of the computations and how Python works out an answer using the BODMAS system, which is how mathematical operations work. And it's going to stop you getting loads of errors. And after that, we jump right into our first project. Our project was to use everything we know so far about variables and numbers to make a health potion functionality for a video game. In this project, we learned how numbers are used in programs to represent real-life concepts, such as health and difficulty. We also learned how to import external Python modules into our code for added functionality, using the import keyword. We used Python's random module to help us make a random number generator. We also learned how to cast variables from different types, particularly from a float into an integer. Then, for those of you who are interested, we had an optional lecture which did a deep dive into the Python math module, showing you things from how to round numbers all the way to doing trigonometry and logarithms. The main takeaway from this lecture was that Python is very capable programming language for all the mathsy stuff, but be sure to check out the NumPy, SciPy and Pandas libraries if you're looking to do more complicated stuff like scientific data analysis. Also, don't worry if you didn't grasp everything in that lecture, it's there for reference for life, you've got it forever, so just come back to it when you need it. I mean, wow, just give yourself a big pat on the back for how far you've come. I'm honestly so proud of you, and you should be too. We've covered a heck of a lot of ground in this section, so to make sure you've got the key points down, we have some quizzes and coding challenges coming up to check your learning. After that, you'll have fully completed the numbers section of the course, and you can officially call yourself a Python maths wizard, if such a thing exists. But numbers aren't everything. The next section of the course will cover how to deal with text in Python, and for one of our projects we'll create a program that can take any user input and use that to write sentences about anyone in the world, or anyone imaginary. It's going to be a really amazing section of the course, as text is so fundamental to many user experiences that you're going to be creating with your programs. So good luck with the quizzes and code challenges that are coming up, and I'll see you in the next section to learn all about text in Python.